Once again, welcome dear people watching my previous year question session today. So now we are back with the previous year questions of Haloalkanes and Haloarenes chapter. That will be the April 2024 April shift. April phase questions will be discussed today in the session. So we have the questions in front of us. The first question from April 4th shift 1. Identify the correct set of reagents or the reaction condition X and Y in the following set of transformations. So what is happening? We are having CH3, CH2, CH2Br. We are using an X reagent and converting it into a product. Now after that, we are using some Y and converting it into something like this, right? Yes. So what is this X? It's very simple. What should happen here? First of all, this thing should convert into an alkene. Then only we can have the what? Markovnikov addition, and we get the following product. So for that, X should be something that changes this A into what? A double bonded alkene. So therefore X should be concentrated alkali. Check. Yes. So concentrated alkali. Yes. In second question it is concentrated NH2. So first and third options are wrong. We can eliminate them. So it is 2 or 4. Now to convert this alkene. So what alkene do we get? We get alkene like this: CH3, CH2. This is the alkene that we'll get. Now this alkene should be converted into this thing using a Y reagent. This thing means you should use a Markovnikov addition. Using Markovnikov addition, we are converting it. So for Markovnikov addition, what should we use? Should we use Br2 and CHCl3 or HBr and acetic acid? Yes, for Markovnikov rule we should use HBr and acetic acid. So option 4 is the correct answer. So next question. So next one is the Sandmeyer's reaction. Right, Sandmeyer's reaction. The number of halobenzenes from the following that can be prepared by Sandmeyer reaction. So Sandmeyer reaction means which all thing? We can prepare cyanide, chlorine and bromine substituted products. This X can be CN, Cl or Br. Okay. Here so 1, 2. So number is 2. Iodine is prepared by mixing with Ki. Astatine we have not learned, so we'll just keep it aside. This one can be prepared by HBF4. Okay, so that's the thing. So only 2. So answer will be 2. So next question will be, yes, our next set of question is here. No, one second, 2 or 3 more options are left. Let me check the options. Yes, in this question we have a compound. This is our compound. This compound is mixed with OH minus and C2H5OH. Now what happens? Yes, here we are having a polar protic solvent and alcohol. Polar protic solvent and alcohol. Elimination will happen. For elimination reaction, this Br should go from here. Which one is possible? Right, which one will be possible? We'll just check. Br is the thing going. Br should go. So this thing is possible. This is wrong for sure. A double bond will be formed for sure. This also can be possible, but this CH3 one, this is never possible. So there are 2 answers possible. But look, which one will prefer Zaitsev rule? Zaitsev rule is telling that the double bond. What is Zaitsev rule telling? One second, I'll read the line of Zaitsev rule from NCERT. One second, sorry. Yes. In NCERT, Zaitsev rule is written in a detailed manner. In a definition of Zaitsev rule is given. Zaitsev rule. One second, sorry. In dehydrohalogenation reaction, the preferred product is the alkene which has greater number of alkyl groups attached to the doubly bonded carbon. Greater number of alkyl group attached to the doubly bonded carbon. Okay, greater number of alkyl group attached to the doubly bonded carbon. So here, if Br is falling to here, we get something like this, CH2. Yes, this is one product. Another product formed will be this thing. That's the bond is falling here. Which one is preferred, 1 or 2? It's very simple to answer. Look here, we are only having this side, we are having 1 substituted, but check here, we are having more number of substituted alkene, alkene group, alkyl, one second, sorry, more number of substituted alkyl groups, is here in this 2. Therefore our answer will be, this will be wrong. So option 3 is our answer. Okay, now next question. Yes, we are having our next question here. So I copy 2 questions, so we can do 2 questions. Yeah, nice. The major product of the following reaction sequence are product A and product B. The total sum of pi electron in product A and product B are product A. What's it? Yes, first one we'll have Br2, bromine, Br2. Br2 means we'll be having, one second. Yes, so A will be, yes, so here we are having this thing, right? Now I am reacting it first with the both the sides. We are first reacting with the Br2. What we will get? We'll get 2 Brs attached like this. That's simple. So 1 is common to everyone. Now this one, that is, one second, sorry. Yes. Now that one, that is, this product is reacted with a nucleophile, that is, one, two, three, one second, C, triple bond C, C-O-N-A, okay, C-O minus N-A plus. We attach to this. This is a nucleophile, and only one nucleophile is used here. So any one position here or here, this will go and attach. Let us attach it anywhere and we'll write the formula. Br, which is attaching here. So we'll get O, C, triple bond, C single bond, triple bond C. You add hydrogen. We only need pi electron. That way only pi electrons is marked here. You can add hydrogen to the valency. Okay, you can add it if you need. But to make it fast, I am doing like this. Okay. Yes. This thing. Now, how many pi electrons is here in this product? 1, 2, 3, 4. 4 pi electrons. Now next, there's another part. This is the product A. This is product A. Now for product B, it is treated with alcoholic KOH. What happens? The bonds will fall like this. And hence we'll get 1, 2, 3, 4. 4 pi electrons. So total number have been asked. So 4 plus 4, that will be, this is the product B, okay. 4 plus 4, that will be equal to 8. 8 pi electrons. That's the total number of pi electrons. Simple question. Now, question number 5. The correct arrangement for order of nucleophilic electrophilic substitution reaction of the above compounds. Electrophilic substitution reaction. Most electrophilic substitution reaction for this one, we have discussed it in the part 1 for January session. I told that plus I effect plus M effect. Now second highest for this one. No, not second highest, sorry. This first one is plus I and plus M. The second one is having no special effect, but it's a neutral group. This fourth one is very important. C is attached to an electronegative atom. So it will be having what? Minus I effect. and minus M effect preferably. But 3, it is having plus M and plus I effect. Plus I effect. Good. So the order for the same will be option 1. Sorry, here it is not plus M, it's hyperconjugation, the hyperconjugation effect. Here we are having plus M effect. Very important. Plus M effect means more electrophilicity. Now this fourth one I told it's having minus I effect. That's the reason. Okay, so 1 is the answer. Now next question. The next question is this one. Which among the following compounds will undergo fastest SN2 reaction? SN2 reaction means nucleophilic substitution, second order reaction. And the following compound will undergo fastest SN2. Which will undergo fast? Order, tertiary, secondary, primary. Orders like this for SN2 reaction. That's the thing which will matter here. Look. Here, this is primary. Therefore, the answer will be which one? This is the answer. Nothing to think. This is primary. This is what? 1 second. But still, this is having more steric hindrance. Because next to it there is another group extra attached to it. But this doesn't have such a group. So it will be easy for the transition state to happen. Okay. For this one, it's secondary. For this one, it's tertiary. So 1 is the answer. Simple question. Next question. Yes, next question is this one. SN2 reaction are stereospecific, indicate that they result in formation of only one stereoisomer as a product. SN1 reaction generally result in formation of a product as racemic mixture. First I'll deal with statement 2. SN2 reaction generally result in formation of product as racemic mixture. Correct. Because I told you it is SN1 order, it is racemization. SN1 racemization, SN2 inversion, racemization. Okay, that is correct. SN2 reaction is stereospecific, indicating that they result in formation of only one stereoisomer as a product. Yeah, because only inversion. One stereoisomer means inverted product is preferred. Inverted product is preferred. Right, one second, something happened, my god. Inverted product is preferred. So I think both the statement 1 and 2 are true. Let me check the answer. Yes, both the statements are answers. Because this thing I told, this thing is like SN2 reaction only one stereospecific, because only inversion happens. Retention doesn't happen, only inversion happen, right? That's the thing told there. Both are correct. So this question is over. Now next one. 1 second. Yes. Next question is here. So it's an assertion-reason question. It's an assertion-reason question. Okay. SN2 reaction of C6H5CH2Br occurs more readily than SN2 reaction of CH3CH2Br. We'll just check. C6H5 means benzene ring is there. Benzene ring is there. We'll write 1 second. CH3CH2Br. These are the two compounds given. SN2 reaction occurs more readily than SN2 reaction of. Look, they are telling that SN2 reaction of this compound happens faster than this compound. Really, the statement is what? Wrong. The statement is wrong. Why? You have learned that for benzene, SN2 reaction is difficult. SN1 is preferred because stability of benzylic carbocation. SN2 is difficult because steric hindrance. Steric hindrance. Reason is steric hindrance. But for this one, this is very simple hydrocarbon. Primary. So stability is very high. And less steric factor. Right? Steric means what? Lesser interruptions, because this is very simple compound. There is no many substituent group and all. But here, look, very big benzene is standing here. It's very difficult for a thing to come from the back side and join during the transition state. So really, the first statement is what? Wrong. It's really the opposite way. Okay. Reason: the partially bound and unhybridized p orbital that develop in the trigonal bipyramidal transition state is stabilized by conjugation within the phenyl ring. Reason is correct, right? Reason is correct. So So assertion, one second, assertion is not correct, reason is correct is the answer. Okay? Yes. Sorry, one thing is there that we forgot to dealt with one thing that I didn't think. So that way the answer is wrong. That we do. So our reason is correct, that we know. But assertion, it is also correct. Because they are telling that CH3, CH2Br, CH3, CH2Br, it's told like this, right? It's told like this. I'll explain it. It needs explanation. It's difficult to understand, needs explanation. Okay. The reason why this is stable is that during transition state, there is a partial positive charge developed. Let me check the previous questions that we did on transition state. No, it's not here. We did it not today. We did it last haloalkane haloarene class we did. During transition state, X is coming and not X is coming, sorry. Nucleophile is coming and CH2 is here. And the other thing, one second, I should make it somewhat beautiful. A nucleophile is coming. Here a partial positive charge will be developing because through here some other atom X minus is also leaving. So there's a partial positive charge in phenyl ring. This partial positive charge, what happens here? Their resonance happens because of this partial positive charge. Resonance stabilization happens during SN2 reaction due to this partial positive charge. But in the case of this group, there is no resonance stabilization, right? No. That's the reason why this statement is correct. Because of resonance Ca6H5 CH2Br is more stable. So assertion is also correct. Sorry. So assertion and reason both are correct, and reason is the correct explanation of assertion. That's the answer. Now next question. Yes. So this question is about exciting question, really good question too. One good question in JEE mains. Okay, we are having ClBr. This is our compound. First, this is treated with Na and Et2O. This reaction with Na, it's called Wurtz reaction. You learned in haloalkane. Wurtz reaction, right? Wurtz reaction. What happens in Wurtz reaction? It's like Rx, 2Rx plus 2Na gives R plus 2NaX. This is the reaction, Wurtz reaction. So what happens here is that it's your liking. You can throw off bromine or you can throw off chlorine. But here I am throwing off bromine. That bromine bond is being cut. I am thinking like that. So we'll get Cl. This is the compound formed after Wurtz. So this is the product A. Now after that we add two different reagents and we get two different products. First let us add COF2 cobalt fluoride. In your NCERT we know that when you are adding something related with fluoride, AgF, Hg2F2, COF2, SbF3, the reaction is termed as what? This reaction is termed as Schwarz reaction. Schwarz reaction. So what happens? The halogen atoms will be replaced by fluorine atom. Like chlorine and bromine atom will be replaced by fluorine atom. So our answer is this. So this is the product B. C. So hence this is not our product. It is 3 or 4 is our answer. Okay. Now we'll take the next reaction. Now we are having A with us. A is with us. That is chlorine. A is with us. Now what are we going to do? What are we going to do? We are going to add MgETO, MgETO and D2O. MgET2O, ET2O, MgET2O. What is ET2O, kids? What is ET2O? It is not water. ET2O is what? It is diethyl ether. Diethyl ether. ET2O is ether. Why we showing ET2O means ET2O is what? Dimethyl ether. Dimethyl ether. It is not water. Okay, dimethyl ether. Many of the people are thinking it's something like H2O. It's ET2O is dimethyl ether. Why we are showing this? It's like for Wurtz reaction we need ether medium. And for this reaction, that is preparation of Grignard's reagent, it happens in what? Which medium? Which medium? Which medium? Tell. Which medium? It happens in? Yes. It happens in ether medium. So here Mg and in ether medium what happens? The halogen atom will become MgBr, MgX atom, MgX. So the thing will become MgCl. One second, someone is outside, I'll come. Sorry for the disruption. So we will get MgCl, something like this. Yes. This thing is in your NCERT textbook. Page number, one second, I'll tell now. In NCERT textbook, preparation of Grignard reagent is there in which page? One second, sorry. Yes. Which page? My God, it's very untidy. My book is... yes. It's there in page number 180, reaction with metals, Grignard reagent. Okay, Grignard reagent. So we get MgBr. This is Grignard's reagent. Now what happened? Into Grignard's reagent, if we add water, it reacts violently. If we add water to this, it reacts violently to form the corresponding hydrocarbon. So this MgCl will go. We get the corresponding hydrocarbon. This is the corresponding, and this will be the product B. Okay. The problem is that here we are not adding H2O, we are adding D2O. If D2O is added, instead of H, D will be substituted in the place. So the answer will be option D. D is the correct answer. Only option 4 is the correct answer. Okay, option 4 is the correct answer. So good question. Now next question. Yes, this is the last question in the April shift paper, I think. So this is the question. We are having, one second, sorry. We are having a big compound like this, OCH3, Br. This thing is there. We are adding alcoholic KCN. Okay. When we add alcoholic KCN, nothing is happening. Just what happened? Nucleophilic substitution reaction will happen. Nucleophilic substitution reaction will happen. It is KCN, not AgCN. If it was AgCN, we will get isocyanate. If it's KCN, we get cyanide. So just to replace the Br with cyanide. Simple question. Simple but humble question. OCH3, just to make it Cn. And this thing is there. Okay, so this is the answer. Option 4. Yes. By this, the questions from the chapter Haloalkanes and Haloarenes of 2020 paper come to an end. This session was very short. The previous session was long. The session was short enough because questions asked in April was simple compared to January shift. Okay. Yes. Thank you for watching my video. Thank you.